Okay, ladies, I'm going to try and do this again because I messed up my first calculation because I was rushing it because the day that was in it, last day of school. So I'm going to try this again. Okay, so this is a question from your workbook, okay, and it's all about stoichiometry too. We have ammonium chloride 20 grams and calcium hydroxide 20 grams, and we're being asked which material is in excess. Remember, excess means it's the material which isn't going to run out. It's the one that there's lots of, whereas the limiting reagent is the opposite of the reagent that's in excess. It's the one that will run out. Okay, so first thing to do when you get a question about excess and limiting reagent is to work out the moles in both cases. Okay, so to work out the moles, we have to go back to our famous triangle. You know the one. Okay, here we go. So mass, moles, AR or MR. Okay, remember that's the mass that you have, that's the number of moles, and that's your molecular weight in this case, okay, not rather than atomic weight. Okay, so if we're looking for the moles, you cover over the moles, and it's going to be your mass that you have, your 20 grams divided by the weight of each one of those compounds. Okay, so let's do NH4Cl first of all. Okay, so NH4Cl, we've got 20 grams of it. Okay, we're going to have to divide it by the weight of that. So let's work out the weight of your ammonia chloride there. So it's going to be 14, that's the mass of the nitrogen, plus 4 by 1, because that's hydrogen, plus chlorine, which is 35.5, okay? When we add all of that up, that works out to be 53.5 grams. Okay, so 20 grams divided by 53.5, that will give us the number of moles of our ammonium chloride. So let's put that into our calculator there, and we get 0.37 moles. Okay, that's for your ammonium chloride. So put a little bubble around that. That's not so bad, okay? Now let's do the next one, which is your calcium chloride, CaOH2. Now remember, that bracket means you've got 2 oxygens and 2 hydrogens there. So let's give this a go. So again, we're going to have to divide the mass of it that we have, the 20 grams, divided by our molecular weight of our calcium hydroxide. So let's work that out. So CaOH2 is equal to, our mass of calcium is 40 plus 2 by 16 for the 2 oxygens, plus 2 by 1, and when we add those up we get 74 grams. Okay, so it's going to be 20 grams divided by 74 grams. Okay, and that will tell us our number of moles of calcium hydroxide. So when you put that in, we get 0.27 moles. Okay, so now we know our number of moles of calcium hydroxide. So this is when we refer back to our original equation. Okay, so over it, I'm just going to put in our number of moles. So we have got 0.37 moles of our ammonia chloride, and we have 0.27 moles, let's write moles after that, of our calcium hydroxide. Okay, so the one that's in excess is the one that we've got more moles of. So this is our reagent in excess. So I'll just say that. So that's in excess. Okay, and this is our limiting reagent. Okay, that's the thing that's going to determine how much product we make. Okay, the thing that you have the least amount of is what will determine how much product you make. Okay, because obviously that's the stuff that's going to run out first. Is that okay? Okay, so let's move on to the next part of the question, which was working out our theoretical yield. Okay, so grab another whiteboard. Okay, so let's write down our equation again. So it's going to be 2NH4Cl plus CaOH2. Okay, arrow 2NH3 plus CaCl2 plus 2H2O. Now we're being asked to work out our theoretical yield of 2NH3, okay, our ammonia there, all right? So let's write down our moles again. So our moles again are, let's write them down. So it's 0.37 moles of that, and it's 0.27 0.27 moles of our calcium hydroxide. This is our limiting reagent. This is going to determine how much product we make. Okay, so we're going to have to look, because we're going to be looking at the balanced equation here. All right, we've got two of these guys, one of these guys based on the balanced equation, 2 ammonia, 1 calcium chloride and 2 waters. Now the only thing we're really worried about here is your 2 ammonias here. Okay, so if you've got 0.27 moles of calcium hydroxide, you have 0.27 moles of your product multiplied by 2. Okay, let's put that into our calculator and work out what that is. So it's 0.27 by 2. Okay, so that is 0.54 moles of ammonia. Now usually when they're asking you for theoretical yield, they're asking you for mass. Okay, so again we have to refer back to our special triangle here: mass, moles, AR or MR here. Okay, so it's going to be, if we're trying to work out our mass, cover that over with your finger. It's going to be moles multiplied by your molecular weight of ammonia. So we're going to have to work out our molecular weight of ammonia over here. So NH3 is equal to 14, mass of 14 is just nitrogen plus 3 by 1, which is equal to 17. Okay, so let's multiply our moles. 0.54 by 17. That will tell us how much ammonia we have there in grams. So 0.54 by 17, that is equal to 9.18 grams. Okay, that is the maximum amount of ammonia we can ever produce. Okay, that's if the reaction goes the best. If it's not reversible, that's the best possible outcome. Okay, so now we're going to have a little look of actual yield. So imagine if the question said, no, you didn't get 9.18 grams of ammonia, you got 4 grams of ammonia. Okay, what is the yield of ammonia if you've gotten 4 grams? So let's look at this. So it's just like getting the percentage of a test here. All right, so it's going to be, imagine your 9.18 grams is what the total test is out of. 4 grams is what you've actually got. You're trying to work out the percentage. So it's going to be 4 divided by your theoretical yield multiplied by 100. Okay, so that is going to be 4 divided by 9.18 multiplied by 100. So our actual yield is 43.57%. We usually round that to a whole number if it's a percentage. So that is equal to 44% actual yield. All right, remember the actual yield is what you actually get out of the reaction, if I can speak, and you'll very rarely get 100% yield out of it. You'll actually never get 100% yield out of a reaction, so that's very normal. All right, so I hope that makes more sense. Thank you. Bye.